Okay, so today's lesson continues off of yesterday's lesson. Remember, yesterday we were talking about um, how geometric sequences can be written uh, recursively, and we were tying that into what we knew about exponential growth. So you should have checked your homework already. That's posted on Classroom. And now you are looking in your notes packet at lesson 3. So let's take a look at number 1. Cameron was offered a job that paid a salary of $36,000 in its first year. Then the salary was set to increase by 2% every year after. So if we were going to set this up, we know that we have our formula, A equals P times 1. This is going to be increasing, so it's 1 plus the rate to the amount of time that this is happening over. So here, if they just want the recursive formula, this is just like yesterday. So again, for some people, it helps them to set up the function. Oops. So let's see. If I set up the function, do they want us to use n? Yeah, after n years. So here we are starting with 36,000, and it's growing at 2% every year. So we're going to say 36,000 times 1.06, and again we're adding that rate because it's increasing by 6% to the n. So that would be a function, but they want a recursive formula. So just like we did yesterday, we could write the recursive formula by saying A0 equals 36,000. We're going to use A0 because that would be how much you make the first year. And then if I wanted to find some year n, it would be A7 minus 1 times 1. Oh, I'm sorry, that should have been 1.02 before, not 1.06. Okay, so that's what we did yesterday. So now we're just going to take it a little step further, and we're going to use the geometric series formula. So remember, a series means that I'm taking my sequence and I'm adding up all of the pieces. So again, this is one of those formulas that you get for free on the reference sheet. So you don't need to have this memorized, but because I'm not sure if you have your reference sheet in front of you, I'm going to just write this out for you. So remember, the formula was A1 minus, oh, my pen doesn't want to work. Let's try that again. I think if I click erase, it's going to erase it all. So it was A1 minus A1 times R to the n over 1 minus R. Now you just have to be really careful here. R is talking about the common ratio. So our first term, or the beginning part of our sequence, was that first salary that we got. So that was 36,000 in the first year. Minus 36,000, because that's still what we start with. The common ratio is 1.02. Now, they're saying n years, so we're going to leave this as n over 1 minus 1.02. Now, because they told us in the directions to write a geometric series formula S sub n, they actually want us to get fancy, so we're going to say this equals S sub n. Now, as a follow-up, they're going to ask us, okay, well, now we want to actually plug in a certain amount of years. So they're going to ask us to actually put 13 in for the number of years. Now, the key word that lets me know that I'm using a series formula and not just subbing in to find the 13th year on its own is they ask me to find the total amount of money earned over 13 years. So make sure you're being picky and you're answering the question they're asking you. So all we need to do is, now that we did the hard work to make the formula, we're going to put 13 in for n, and we're going to show that in our work under here. And then we're going to look and we're going to read carefully. It says nearest whole number. So when you toss that in your calculator and you round to the nearest whole number, you're going to get something around, let's see, 528,492. And when you get your answer, you really want to think about it for a second and make sure it makes sense. If you have something that started at $36,000 in the first year and you're totaling that amount of money every single year over 13 years, and it was increasing by 2% on top of each year, it makes sense that it should be something close to that amount. The other thing you want to keep in mind, remember, in our calculator, we can actually pull up the format for the fraction if you hit alpha y equals, and it'll give you a box over a box to input the whole fraction. It makes it a little cleaner and easier to type in. Okay, so I'd like you to pause the video at this point, and I want you to read through question 2, and I want you to try to set up what the general formula would be for this fishing company. And I really want you to be a picky reader when you look at this and think about what's going to change when it says the word decreasing. Okay, so at this point, you've given it a try and you've read through the question. So one thing we need to be careful about here is they do tell us the amount of fish that they're starting with, but it's actually a declining situation. The population is decreasing because they're catching the fish. So let's see here. We know that we're starting with 170,000 fish, and if we're losing 8% per year, then it would be 1 minus 0.08, and I'm going to get 0.92 in my parentheses here. If I'm writing this as a function, I could say f of n equals this, and then this would be raised to the n. Now, when we think about this, let's see. They want to know how many total fish did the company catch over 8 years. And we're going to be rounding to the nearest whole number here. So when we look, when we see the word total, we know we're going to be using this sum formula for series. So remember, you get this formula for free, but you need to know when to use it. So here we need our first term. So that's always going to be like the starting population, or the starting amount of money, or the starting amount of grams you have of some type of radioactive element. And let's see if we can figure out all the different pieces that we need. So here n is 8 because it's over 8 years, so we can get fancy and say S8, and then A1. That's what we start with. So that's 170,000. Minus 170,000. And then our common ratio here is 0.92. So one thing that's really key for people that I would highly recommend that you do, even though you don't have to, they don't require you to write this function here, I think it really helps you find what the common ratio is, and it's going to make your life easier when you're trying to substitute into this formula. Now here we're going to put 8 in for n because it's over 8 years, and then it's 1 minus 0.92. Now again, I would definitely use the trick on your calculator where you can do alpha y equals, and then you can type this in as one big fraction. That'll alleviate any little stinky poo-poo math mistakes that you make. Then when we go to our calculator and we type all that junk in, we're going to get something that's in a little more than 1 million. So I'm just going to do a dot, dot, dot. So I got something that was like, let's see what happened here. 1,034,409.89. Now, you want to keep in mind, we need to round to the nearest whole number, and they want to know how many total fish. I wouldn't round up because we're not going to count like a piece of a fish as a fish they caught. They can't really sell like part of a fish. So I would actually keep this with the 9 on the end. So I'm going to say something that's approximately, and again, we're just approximating, 1,034,409. Okay, at this point, I'd like you guys to try number 3 and number 4. Now, when you try number 3, you're going to be so excited because we're going to do a little bit of editing here. So for number 3, you can, oh, I lied, we're going to do all of number 3. So for number 3, you're just setting up the formula, and then they want to know how many videos would have been watched on the 23rd day. Actually, I want you to toss part B, so you can cross out B. So that's out of here. So you're just doing part A, and then you're going to complete number 4. After you've completed number 3A and number 4, you're just going to check in with the sub to make sure that you have the correct answers. They're going to have a copy of my answer key. And once that's perfecto, they're going to give you a copy of the homework, and you can get started on that. Have a good day, guys.